The unit circle is a very important topic in trigonometry and can be defined as the circle on the xy plane that is centered at the origin and has a radius of 1 unit. Let's think about what the equation of the unit circle would be. In a previous math class, you would have seen that the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where the center of that circle is h comma k, and r is equal to the radius of that circle. So here, this is the ordered pair 0, 0, and we know that it is a circle of radius 1, which would mean, for example, that this point here is 0, 1, this point here is 1, 0, this point here would be 0, negative 1, and this point here would be negative 1, 0. Now, because this is the unit circle, we can fill in the values for h, k, and r. We know that the center is 0, 0, so we could write x minus 0 squared plus y minus 0 squared, and we know that the radius is 1, so we can write 1 squared. And if we go ahead and simplify this, this is just going to end up becoming x squared plus y squared is equal to 1. And it turns out that this is the formula for the unit circle. Not too bad, right? Do you remember the quadrants of the xy plane? Let's quickly review those. So the xy plane is split up into 4 quadrants, and the way we label them is this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So we start in the top right section or region and then work our way counterclockwise and labeling them 1 through 4. Let's go back and do some review of some geometry topics. A triangle has 3 angles and 3 sides. To solve a triangle means to identify the measures of all 3 angles and the lengths of all 3 sides. Let's look at a specific triangle. Consider the following equilateral triangle of side length 1. Drawing one of the heights will create 2 new similar right triangles. Solve the new triangles. So if I took out my handy dandy ruler and I drew a line right down the middle of this triangle, that would form a right angle, which, if you remember from the last section, a right angle is 90 degrees. And before we drew that vertical line, because this is an equilateral triangle where all the side lengths are 1, that means that all of the angles are equivalent as well. And hopefully you remember from geometry that all of the interior angles of a triangle need to add up to 180. So that means that each of these angles is 60 degrees. Now, if I'm cutting this in half, then this angle here now, if I'm looking at this smaller triangle, because we cut it in half, this is going to be 30 degrees. And I've also cut the length in half. So that means that this length here is going to be whatever half of 1 is, which is 1/2. So I'm almost done solving this triangle. The only length I don't know is the length of the height here, because I know that this bottom side length is 1/2. I know that the length here, which is called the hypotenuse, I know that's 1, but I don't know, I'm going to label this height, let's call it A. I don't know what A is. Fortunately, we have what's called the Pythagorean Theorem, which we learned in geometry, that says that if you have a right triangle, if you square the lengths of the sides and add them together, that's going to equal the square of the length of the hypotenuse. So I'm going to fill in these values since we know some of them. I don't know the a squared value, but I know that b is equal to 1/2, and I know that c is equal to 1. So let's go ahead and try to solve this for a now. So I have a squared plus 1 squared is equal to 1/4, and then 1 squared is equal to 1. So now I'm going to go ahead and subtract 1/4 on both sides. And that's going to say that a squared is equal to 1 minus 1/4. And I'm going to find a common denominator. So that's going to say that a squared is equal to 4/4 minus 1/4. And then I'll come over here, and we get that a squared is equal to 3/4. Now, I want to take the square root of both sides. And so a is going to equal plus or minus the square root of 3 over the square root of 4. Now, a couple things here. A represents a length, and normally when we're talking about lengths, we don't refer to lengths as negative values, so I'm just going to erase the negative sign. In fact, I'll erase both of them. And the other thing is, we know that the square root of 4 is 2, so I'm just going to write this as 2. So ultimately, we get that a is equal to the square root of 3/2. So now we've figured out all of the side lengths and all of the angle measures in the highlighted triangle. So we've gone ahead and done what the question is asking of us. The next part says, now consider the following square. Drawing a diagonal will create two similar right triangles. Suppose the diagonal is 1 unit, solve the triangles. So I'm going to draw a diagonal here, and according to the setup of the problem, the length of the diagonal is 1 unit. And if you remember from geometry, the sum of the interior angles of a square need to add up to 360 degrees, which tells us that this is going to be 90-degree right angle, and this is going to be a 90-degree right angle. And if we cut that diagonal, that's going to tell us that this is half of 90, which is 45, and this is also going to be 45 degrees. Now, I'll label this length A and this length B, and there is a theorem in geometry that tells us that if this angle in our triangle and this angle in our triangle are the same angle, that means that A and B have to be the same length. And that's going to be really important when we're using the Pythagorean theorem to figure out what A and B are, because again, using the Pythagorean theorem, we get that a squared plus b squared equals c squared. Now, the only value that we know in that equation so far is the length of the hypotenuse, which is 1. And if we have a single equation like this, we can't quite solve for it if there are two unknown variables. However, we can make the substitution. This is an isosceles triangle. It would probably help if I spelled it correctly. So isosceles triangle. So A and B are equal. So if A and B are equal, then I can make a substitution in my equation here and say that a squared plus a squared is equal to 1 squared. And so if I combine like terms now, we get 2a squared is equal to 1. Then I can divide both sides by 2. And so we get a squared is equal to 1/2. And now I'm going to take the square root of both sides. And we get a is equal to Normally I'd put plus or minus, but just like in the previous example, we want to ignore the negative values. So I'm going to do square root of 1 over square root of 2, and that's going to be equal to 1 over the square root of 2. Now, hopefully you've learned in a previous algebra class that normally in math, we don't like there to be a square root in the denominator. And so our way around that is we rationalize the denominator by multiplying this fraction by the square root of 2 over the square root of 2. And that's okay because that's just equal to 1. So we're just changing not the value, but what that number looks like. And so a ends up equaling the square root of 2 over 2. And so we have found our a value, and b we established earlier was the same length. So we've now solved the triangle that I've highlighted here. We found all the angles and all the side lengths. So we have completed this question.